Assalamu alaikum. I welcome you all to this video lecture on steel structure. In this particular video lecture, we will be discussing about the numerical and effective area. Effective area is very important in finding the failure of tension member in fracture. In fracture, this effective area will be used. So it is very important in design of tension member. So while designing a tension member, we will be discussing two limit states. The one is the limit state in yielding, and other is in fracture. In yielding, we use the gross area. In fracture, we will be using effective area. So while finding effective area, we need two things. The number one is the area. In case of yielding welded connection, we need the gross area. In case of bolted connection, we need the net area. And second thing is the shear leg reduction factor, that which type of shear leg occurs and what will be the value of U. So it is the product, effective area is a product of this U, shear leg reduction factor, and the net area in case of bolted connection, and the gross area in case of welded connection. This will be the today topic, that how we will find the effective area. This lecture will be the general type lecture, in which we will discussing the stepwise that how we will solve effective area in different cases. The only difference occurs that what will be the value of U. In case of there are 5 categories for finding U. The number one is equation, the second one is for plate, the third one is the hollow structural steel, and the fifth and fourth are the alternative values for these. So in this lecture, we are only focusing on how to solve a numerical and effective area. So here it is a question that determines the effective area if the dia of bolt is 1 inch. Remember this. So here 3 bolts are used. This is a gusset plate, and this leg angle section is connected through 3 bolts. It's not welded connection. From this we will know the connection type. This is the bolted connection. Here you see the cross section view of the connection and leg and the gusset plate. So here this is the angle section. So we will defining the effective area. So the first step is that you should determine the gross area of this section. From gross area we will find the net area, and then we will get the U, that how we will determine the U. So from this U, first step is that find the gross area for this member. Sorry. For this we will using the steel manual table, that here the size of the dimensions of the angle sections are given. So we will be using the steel manual. So we will get the effective area for this. Here it is the steel, from steel manual I get this screenshot, that for this section L 3.5 into 3.5 into 3/8 is the thickness. For this the gross area in this will be the 2.5 inch square. Remember this. How we'll get that? You should go in this section shape. So here the section shape is this. In this row there are different properties for this shape. So here the properties is the area, radius of gyration, weight. So all the properties are given. Sectional modulus. So here we will only need the gross area. In gross area row we will get the area of the this type of shape, structural steel. So here this will be the first step. Remember, this is the first step for finding the gross area for this section. We directly go to the steel manual and select the shape of structural steel, and then in area column we will get the area for that shape of structural steel. Here in our case the area is 2.5 inch square. This is the first step for solving effective area. Now the second step for this question will be the net area. How we will find the net area? From gross area, after deducting the area of holes in failure plane. So we will get the net area for this section. Here this will be the second step. Here force is applied in this direction. Here tensile force applies. So the failure will be tensile failure. So cut a section which is perpendicular to the applied force. So this will be the failure section, and failure section is occur in one bolts. Remember this. Here bolts are connected in this way in one line. So the failure will occur in the weakest bolt. So here this will be the failure plane. So the net area will be equal to the gross area minus the area of holes on failure plane. So here net area is this, that 2.5 is the gross area minus how many bolts are in the failure plane? Only one bolts are in the failure plane. So 1 into the dia of bolt is 1 inch plus 1/8 is the tolerance. We will add the tolerance of the bolt. So number of bolts into dia plus tolerance into the thickness of bolt or plates. So here we will using the thickness of bolt. Here the thickness of a hole is the same as the thickness of this section. So here thickness is 3/8 for this section. So the thickness of a hole and thickness of this section will be same. So in summary, that net area, in simple way, the net area is the gross area minus area of holes. Gross area we had calculated from the table, and the area of hole is the number of holes into the dia into the thickness. Here in dia we will add the 1/8. This is the tolerance, and the 3/8 is the thickness of the holes. After calculation you will get this net area, which is 2.078 inch raised to the power 2. This will be the net area. First and second step is same for all type of questions in case of bolted connection. So the third step is that finding the reduction factor. For effective area we need reduction factor and net area. In last slide we had found the net area for this section. In this slide we will be determining the U shear leg reduction factor, that what will be the value of shear leg reduction factor. So here reduction factor for this will be from two categories. We will be finding the reduction factor for angle section. So here it is the angle section. The number 1 is the equation method, and the number 4 category is the alternative values for single and double angle. For equation method we need the X bar and the length of connection. Here length of connection is not given, so we will jumping to the fourth category of finding shear leg reduction factor. So the for alternative values of single and double angle. In this category, number 4th category, for finding the shear leg reduction factor, we had two statements. For 3 fastener in the direction of loading, here the direction of loading is this. In this direction, if we had 3 fastener in the direction of loading, then the value of U shear leg reduction factor will be 0.6. This will be the alternative values. If the number of fastener in the direction of loading is more than 3, then the reduction factor will be 0.80. Remember this. So in this we will use the 4 category for finding shear leg reduction factor. There are total 5 categories I had discussed in earlier lectures also. So here we found the value for U, which is 0.60. So now we had found the value for U and the net area. Now we will just multiply this value of U and the net area to get effective area. So the fourth step will be the last step, that the effective area will be the product of shear leg reduction factor times the net area in case of bolted connection. In case of welded connection, in this net area place, we will get the area gross. So here area effective will be the value of U is the 0.60 we found in last slide, and the net area we found which is 2.078125 inch square. So here after multiplication we get the effective area which is 1.2469 inch square. This will be the effective area, and this area will be used in design of tension in case of fracture limit state. So this will be the whole lecture on effective area, that how we will solve a numerical and effective area. So only two things required. The number one is the shear leg reduction factor, and the second is the net area. So I hope you got it. So thanks to everyone.